This video is on the product of primes, or the product of prime factors, and also on how you find the highest common factor or lowest common multiple of a pair of numbers. So before you do any of these things, you need to know what your prime numbers are. So prime numbers are the numbers that only divide by one in themselves. That doesn't really mean very much until you actually start looking at some of the numbers. So the first prime number is 2, because it only divides by 1 and 2. Then 3, because it only divides by 1 and 3. Then you skip 4, because it also divides by 2, as well as 1 and 4. Then 5 is a prime number because it only divides by 1 and 5. 6 isn't, because it also divides by 2 and 3. 7 is, because it only divides by 1 and 7. 8 isn't, because it divides by 2 and 4, as well as 1 and 8. And then 9 isn't, because it also divides by 3, as well as 1 and 9. 10 isn't, because it divides by 2 and 5 as well. And then 11 is, because it only divides by 1 and 11. Your prime numbers continue on forever, for as long as your numbers do, but those are the main ones that you need to know, the 2, 3, 5, 7, 11. You'll notice there that I skipped out the number 1. That's the number that's the tricky one, that everybody thinks that 1 is a prime number, and it's not, because all of these other numbers have 2 factors, 1 and 2, 1 and 3, 1 and 5, 1 and 7, 1 and 11, whereas 1 only has 1 factor. It only divides by 1, and your prime numbers have to have 2 factors, 1 and then the number themselves. So 1 is not a prime number. So it starts with 2, 3, 5, 7, 11. You'll notice as well there that the only even one is 2. All of your other prime numbers are odd. That doesn't necessarily mean that because it's odd, that it's automatically a prime number, because I skipped out a number like 9, and it's odd, but because it divides by 3, it doesn't fall into this category of being a prime number. So these are the main prime numbers that I'm going to be using them. And the first thing I'm wanting to do is write 40 as the product of its prime factors. There's quite a lot of fancy words there. So product means multiply, but you don't come across it until the end. Prime are those numbers there that we were looking at. And then factors are whenever you divide and split the number up. So starting with the number 40 then. And you want to keep dividing it by these different prime numbers. So I would always start, if you can, by dividing by 2. So 40 divided by 2 gets you 20. Then divide by 2 again if you can, and you can, it will get you 10. Divide by 2 again, gets you 5, and then you can't divide 5 down anymore because it's a prime number, so you stop there. So you've used factors because you've kept on dividing. You've used the prime numbers because 2 and 5 are prime numbers, and then the product bit comes in right at the end here, where you multiply together these numbers and the 5. So you do 2 times 2 times 2 times 5. Which you can also write as 2 cubed times 5 if it asks you to give it in index form. And then if you were to multiply these back out again, 2 times 2 gets you 4 times 2 gets you 8 times 5 gets you back to the 40. You don't actually have to multiply them back out, but you can, just to check that you do get back to the number 40, because that's actually the whole point of it. You're writing 40 out in a different way. So this here is actually 40. It's just written as the product, because it's multiply, of these prime numbers that have all been divided into the 40. Okay, so that's the product of prime factors. It comes in quite handy then if you're wanting to find the highest common factor or the lowest common multiple. You can use those, I call this a prime factor ladder. You can do the tree as well with the branches where you've got the 40 going out like that, but it's quite difficult to find the highest common factor and the lowest common multiple from that. So I would stick to using this ladder method, and I think it makes it a lot easier. So the highest common factor of 120 and 100 then, you do a double ladder. So 120 and 100 all in one ladder, not two separate ladders. The two ladders are joined together. And you keep dividing by your prime number. So we're dividing by 2, 3, 5, 7, 11. And you might need ones higher than that. So divide by 2 first of all would get you 60 and 50. And then both of those divide by 2 again to get you 30 and 25. Both of those then, you can't divide both of those by 2. 30 does, but 25 doesn't, so you can't divide it by 2. So then the next one you'd go up to is 3. 30 divides by 3, but 25 doesn't, so you don't use 3. You go to the next one, so you would go to 5. And both of them divide by 5 to get you 6 and 5. And then you stop there because there's nothing that you can divide both 6 and 5 by. You don't necessarily have to end up with prime numbers here at the bottom. We've only got one prime number. 6 isn't a prime number. So it's not that you go until you've got prime numbers at the bottom. You go until there's nothing that these numbers have in common that they both divide by. So then your highest common factor comes from you multiplying these numbers together at the side. So you do 2 times 2 times 5, and you actually get a number for this. The highest common factor will be a number. You don't just leave it as 2 squared times 5. So 2 times 2 gets you 4, times 5 gets you 20. So 20 is the highest common factor of 120 and 100. So it's the highest number that both of these numbers have in common as a factor. It's the biggest number that divides into both 120 and 100. If you want to, you can stick with the old method of writing out all the pairs of numbers that make up 120, all the pairs of numbers that make up 100, but you could be there for a while doing it that way and you might make a mistake. This, I think there's less chance of you making a mistake. If you were looking the lowest common multiple of 120 and 100, you would just multiply these together in an L shape. So I'm going to look at a question where you're wanting to find the lowest common multiple then. So the lowest common multiple of 48 and 60. So again, you do a double ladder, 48 and 60, and divide it by the prime numbers 2, 3, 5, 7, 11. So divide by 2 first would get you 24 and 30. Divide by 2 again would get you 12 and 15. And then you can't divide both of these by 2, so you jump up to the next one, which is 3, and both of them divide by 3, okay? So that would get you 4 and 5. And then you stop because there's nothing that you can divide both 4 and 5 by apart from 1, and you don't want 1 anywhere in these ladders. So that's you done with that one. If you wanted the highest common factor, you would do the same as what I did in the last question, where you multiply the 2, and the 3 together. But whenever you want the lowest common multiple, you multiply the numbers together in an L shape. So that should be easy enough to remember because lowest common multiple has an L in it. You're looking for the LCM, and to get the lowest common multiple, you multiply the numbers together in that L shape. So you do 2 times 2 times 3. 2 times 2 is 4 times 3 would get you 12. And then you're multiplying that by 4 and then by 5. I would normally multiply the ones down the side together first and then the ones along the bottom together. And then we're multiplying 12 by 20. So multiplying those two together then, 12 times 20, do 12 times 2 is 24, and then stick the naught in the end. So 240 is the lowest common multiple of 48 and 60. It's the lowest number that they have in common as a multiple, or the smallest number that's in both their times tables. Okay, that's the end of that video.